Okay, so now we're going to work a Riemann sum problem. So we're going to let f of x be defined to be 1 minus x squared, and we're going to find the sum over the interval 0, comma 1, closed interval. So first thing to do is to convert this to the limit of the Riemann sum format, which, as we know from the last video, is limit as n approaches infinity of the sum k is equal to 1 to n of f of x sub k superstar delta x. So to fill this in, what do we need to know? Well, delta x is going to be equal to b minus a over n, and that would be 1 minus 0 over n. So 1 over n, and x sub k superstar is equal to a plus k delta x. So that would be equal to a is 0. K delta x, well, that's k over n, because we know delta x. So x sub k superstar is equal to k over n. And of course, the function is this. So we can transcribe that. Limit as n approaches infinity. Sum k is equal to 1 to n of 1 minus k over n squared, and delta x is 1 over n. So we're going to come down and do this more. Limit as n approaches infinity. Now what we're going to do is break up this sum and pull this. First we're going to pull out this 1 over n. We're going to put that in front of the sum. It doesn't have a k term, so we can do that. 1 over n sum k is equal to 1 to n 1 minus k squared over n squared. So I squared the term inside. Close limit. Okay. So limit is equal, or limit n approaches infinity. Now we're going to break up the sum. So n, oops, k is equal to 1 to n of 1 minus the sum k is equal to 1 to n of k squared times 1 over n squared. So basically I pulled out this 1 over n squared and put it in front of the sum. And now that's the problem. So limit is n approaches infinity, 1 over n. Now here we get to simplify these out using our formulas that we've learned. So, and this is basically the definition of multiplication. You have a number added to itself n times, so that would be n times that number. So, since that number is 1, we have 1 times n minus 1 over n squared. And k squared is, of course, n times, and the sum of k equals 1 to n of k squared is n times n minus 1, sorry, n plus 1, times 2n plus 1 all over 6. And that's the limit. So now it goes back to basically an algebra problem where we get to distribute this all out. So 1 over n times n minus, this is going to be n squared plus n, 2n plus 1, all over n squared, and I'm going to pull out this 1/6 over here, like that. And close this parenthesis, close that brace. Okay, limit is n approaches infinity, 1 over n times n minus 1 over n times 1/6. Now I'm going to factor this out or expand that. 2n times n squared is 2n cubed plus, that would be 2n squared, another n squared, so that would be 3n squared, and then plus a n term, all over n squared. So now, I'm going to extend my whiteboard, hang on. Okay, so now my whiteboard's extended, I can continue on this problem. So, limit as n approaches infinity. This, of course, is just 1 minus, now we get to pull through this n squared term, and that would be 1/6 times 2n cubed plus 3n squared plus n, all over n cubed. And of course we can break apart this limit, thinking back to calculus 1. Limit as n approaches infinity of 1, and of course this goes to 1, but I'm just going to write it out to be explicit, minus the limit, 1/6 of the limit actually, as n approaches infinity of 2n cubed over n cubed plus 3n squared over n cubed plus n over n cubed. Now, we can see here that as n goes to infinity, these are going to go to 0 because we have a larger power on the top and a smaller power on the bottom. This actually cancels out. So we get 1 minus 1/6 times 2. And that goes to 1 minus 1/3, which is equal to 2/3. This is the limit of the Riemann sum as of f of x equals 1 minus x squared from 0 to 1.